Good morning, students. In the CET problems, we stopped at 150 something, 156 I think, 157. Hint is there, you go through that. All remaining problems also hints are given. I just explained some of them. Here we are given the arrangement of the capacitors in this hexagon form. All capacitors are equal to C. There are 2-3 methods are there for this analyzing. One method is mirror reflection method. If you put a mirror here, right side is a reflection of the left side. So whatever charge is here also appears here, and you can divide this into 2 parts like this. If you divide into 2 parts, capacitor if you divide into parts, no, you cannot actually practically divide, but you have to take it as a C in series with C. Okay, it becomes 2C. 2C should come here and join all these left side that comes in series with the right side. Only one side you can analyze. Another method is this charge same here. So these two appears to be in series combination, and you can just remove this joint. Sorry, this is not a open one. This is also capacitance are there here also, please. In the diagram, if it is missing, please check up that. Here also capacitor will be there. Okay, if not there, what happens? I will tell you. In case if it is not there, any capacitor circuit diagrams, if you connect wire like this, the charges don't store on the capacitors. So that part you can simply, if you connect like this, no current directly goes here. All the charges becomes no use. All these capacitors becomes no use. Charges do not stay any of them if this is shorted. So you keep one here. Here also one capacitor is required. Then you separate this and separate this joint. Now what comes is, these two are coming in a series. All are C only. Series identical. In 2 are there means C by 2 it becomes. So between these two terminals A and B, you will get the center one. I am taking equal to C in series is C by 2. Top, these two C and C in series is C by 2. C by T parallel to C. So you will get the term here like this. This one capacitor is here. I can bend, and this is C. Okay, and this is C. This is nothing but equal to combination of these. This is C and C is C by 2, C. Coming C by 2 parallel to C. C by 2 parallel to C. This is A, this is B. What are you calculating top? No. Same thing comes down here also. This part, whatever you calculate, no, you will get the same. Only one side you can calculate, no need to calculate all. Same similar circuit comes for the resistors also, later topic. So what is this becomes is, this is C series with C is C by 2. I am removing this. C by 2 in series with this combination. C by 2 plus C, parallel combination by C is 3C by 2. So this result becomes equal to 3C by 2. 1.5C. This is 0.5C. These are coming in series. C1, C2 by C1 plus C2. Whatever result comes here, no, that comes parallel to C by 2. And also whatever is coming here, that is C by 2. C1, C2 by C1 plus C2 is nothing but equal to C parallel combination. Sorry, series combination, which is equals to, so you take out comma, this is 0.5 into 1.5 by 0.5 plus 1.5. 0.5 plus 1.5 is 2 you will have. Calculate this, how much you get. This is 0.7512 by 2. 0.3 0.375. This whole thing is 0.375. Here also you will have the same value. See, this is also 0.375 C. This is 0.5 C. All are coming in parallel. Okay, and you check up the value with the result. Like that you have to do. This joint you separate and analyze this part. Only one side you do, same comes down. 1, 2, 3 parts. 3 branches are coming in parallel. Calculate the result. And result will be, you will be getting it as 5 by 4 times. 4 by 4 means 0.125. 5 by 4. Result is CAB equal to 5 by 4 times C you will get. That means if you take the fraction, you can take in terms of the C by 2, 3C by 2 only you can take, you will get this relationship. If not, this will becomes equal to correct? You check up the steps calculation, but procedure is just follow and try to work out that. Next problem is 159. In the 159 question, capacitor plates are connected with a metal sheet like this. This is a metal. When you connect with a metal, the electric constant of the metal is infinity. So what happened to the capacitance? C equal to K into C air. But K is how much for metal is infinity. That means capacitance becomes equal to infinity. Next is 160. The means short circuit of the plates it is. 160, which is previously asked once. In this problem, electron enters into a space between the plates of the parallel plate capacitor. These are the plates. So these plates A and B are the plates. This electron is entering Q equal to E, electron charge. Parallel plate capacitor at an angle alpha and leaves at angle beta out to the plates. What is with angle is with respect to normal, not it is with respect to the plates. This is also beta. It is entering like that, some angle going out, and we know the path of charged particle in the electric field is two possibilities. One is a straight line or parabola, only two possibilities. What is the ratio of the kinetic energies while entering and leaving? Here the charge is entering like this, but it is pulled downwards. It try to travel in the direction opposite to electric fields. Electron try to travel opposite to the electric field. So the force acting is downwards, so it will go downwards. Neglect G here. So acceleration is like this here. A equal to QE by M minus E by M. Minus only indicates opposite direction, please, downward directions. Okay. So what remains constant for this one is, it is just like the projectile motion. Neglect A resistance and G. Resistance and acceleration to gravity according to the options given. So velocity is divided into components. You will have the horizontal component U cos alpha, vertical component is U sin alpha, just like the projectiles. And as it changes now, the velocity, force acting on the charges changes its velocity. Velocity changes by the electric field, not by magnetic field. Velocity value do not change in magnetic field. Direction only changes in the magnetic field. But electric field, velocity depending on the position or the direction also changes. Maybe in this case parabolic path means direction changes point to point, and acceleration is there means velocity value also changes, magnitude of the velocity also changes. So initial velocity is u, making alpha with respect to horizontal. If you have taken u is equal to component u cos alpha and u y is equals to u sin alpha, and while coming down the angle is given as a beta with respect to the velocity, final velocity v for example. Initial velocity is u, final velocity is v, so angle is like this. This horizontal component is v cos beta, vertical component is v sin beta. For any projectile motion, it is just like a projectile. Charge moving in the projectile. For any projectile, if you are throwing it, projecting it, no, neglecting air resistance, horizontal component remains constant, vertical component changes. So constant term if you take, it will be easy for us. U cos horizontal velocity, this is ux. This is supposed to be equal to vx. Ux equal to vx. Neglecting air resistance, horizontal component velocity remains constant. Path is parabola and it's like a projectile path. It is projectile. Electron is projectile. You can call it as a electron is similar to projectile, but not gravitational field here, electric field. Projectile in electric fields. What remains constant is horizontal component of the velocity remains constant. U is initial velocity. Okay, ux is equals to u cos alpha is initial horizontal component. Of velocity. V is say final velocity, and Vx equal to V cos beta is final horizontal component of velocity, final horizontal velocity. But for projectile, what remains constant is horizontal component of the velocity remains constant. Horizontal velocity is constant. That means you just have to take this term and this term. That means u cos theta, u cos alpha is supposed to be equal to v cos beta. You are asked to find out the ratio of kinetic energies, I think. What is the ratio of the kinetic energies while entering and leaving? The term important, leaving entering or entering leaving. While entering and leaving the capacitor plates. This is the entering and this is the leaving. So kinetic energy entering, kinetic energy initial equal to half mu square. Kinetic energy final is half mv square. Ratio, if you take a ratio kinetic energy initial by kinetic energy final is equals to half m cancels, so we will get is u by v square, and from this relationship what is u by v? U by v is cos beta by cos alpha. Whole square. So you don't have to take up all this, just remember that horizontal component remains a constant. What is cos theta? So directly go for the kinetic energies. Other points I just written for the understanding purpose only. So you just know that horizontal component remains a constant. So kinetic energy means squares you have to take and ratio you have to take. (161) This capacitor C, bottom plate is fixed and plates have the mass. This bottom plate is fixed to the ground. This is the capacitance C. Okay, this mass, this top plate has a weight that is equals to M2 or M1 is given M2, and it is balanced by other counterbalancing weight that is M1. This is M2 and M1. This plate is mass M2, here counterweight is nothing but equal to M1. So weight acting here is M1G. Here, if unlike charges, this capacitor is charged, for example, this is a plus, this is a minus. Force will be attracting, the force will be there. The force acting is downwards due to the charges is one force, and weight is also acting downwards. That weight is also acting for this plate downward. That is, total force becomes equal to F plus mg, and it is balanced by counterweight equal to m1g. That means m1g is supposed to be equal to this force acting downwards, And force between the capacitor plates already I gave you. Different energies are there. No, energy into distance itself is the force you will have. So here for this plate, F plus mg. What you are asked to find out is expression for, in the figure, capacitor C has each surface plate area A. So you have to use the data given from the question. Plate area is A is given and charges Q is given. That means capacitance formula you have taken in terms of A and Q. The mass of each plate is m2, and lower plate is rigidly fixed. The system is in equilibrium. M1 equal to how much you have to find out. You have to charge given on the plates is Q, and plate area is given as A. So capacitance formula, parallel plate capacitor, capacitance C equal to epsilon naught A by D, and energy U is equals to, we have the three formulas. What are the formulas? These are the pulleys, please. Pulleys fixed, don't bother about it. What are the formulas we have for energy? Energy equal to half CV square, Q square by 2C equal to half Q into V. Any of these formulas we can use according to the data given for us. What is data given is Q is given, A is given. So use that relationship. What is the formula for work? Work is also equal to force into displacement. That is the energy done. Work done to separate the plates with the unlike charges. So energy is nothing but, work is nothing but equal to U equal to work we can take. What to get the relation is, you are given terms of the Q. So we have the charges, we can use either this Q or this Q formula. But V is not given, potential difference is not given. So don't use this Q. Use only Q square by 2C. This is going to be Q square by 2C is equals to, work is nothing but equal to force and distance. C eliminate because A is required, area is given. So take in terms of the area. So we'll get the relationship Q square by 2 into C is epsilon naught A by D is equals to F into D. dd cancels. So force between the charged plates with unlike charges, no, F equal to Q square by 2 epsilon naught into A. The weight acting downwards is this M2G. So total force acting downwards for the plates is M2G. Total downwards force on plate M2 is equal to F plus M2G. It is balanced by M1G. In equilibrium means net force is 0 by M1G. Therefore, at equilibrium, M1G is supposed to be equal to F plus M2G. F is nothing but equal to this formula, Q square by 2 epsilon naught A plus M2G. But we want M1, asked is M1 equal to how much? M1 is Q square by 2 epsilon naught into G plus M2. This is the answer for us. Next, 163. Is related to Van de Graaff generator. Van de Graaff generator is a high voltage generator which is produces static electricity. So it is called a high electrostatic generator. High voltage electrostatic generator. So Van de Graaff not required for right now. That is not of much important. 163. These important ones. You are given the capacitor combination. So already we have discussed this combination, half part of it. 3 capacitors. You take like this, joining like this and joining like this. Okay, this capacitor problem already we have done. How they come? All the 3 is parallel to each other. Result is 3C. Okay, but here in this question, one more is connected in same arrangement is done from here. How it is done is again 3 capacitors. Okay, from here connected to here and here connected to these terminals. All are having the same values. Each value is only C symbol given. Result is example C only you have to take. C, 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 C. This is parallel. This is also parallel. Just separate it into two parts from here. This is one, that one is separate. So what is this? Is C parallel. The C parallel is how much? Is 3C. So up to this point, this is A. This point I will take it as O. And again I will take one more capacitor and then B. What is this? C parallel is C parallel equal to 3C. This C parallel is also equal to 3C. 3C in series with 3C, half it becomes. Identical capacitance series means half. The result is therefore CAB equal to 3C by 2. (1.5C). Next question. These two are problems are important, very important one. Next one also. (164). Similar to the previous problem, but one more capacitor is added on the side branch. Previously we have taken 3 capacitors like this. Like this, but here one more capacitor added here. Similarly here, this shape happens to be different, but it is a well-known structure, circuit diagram for you. It is nothing but a balanced Western bridge. These are all C, 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 C. This one, whatever it is, doesn't matter. So this is nothing but if you pull it like this, okay, you will get a structure like this. This is A, B. This is nothing but equal to C prime, C, 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 C. This is C prime. C prime, whatever it is, does not matter. It is a balanced bridge. Balanced bridge, when you take it as a PQRS. If P by Q capacitance equal to R by S, P by Q equal to R by S, or P by R equal to Q by S, it is balanced bridge. When balanced bridge is there, the potential at A will be equal to potential at, sorry, this is AB taken, no, this we take it as a, some points. C we don't take because C itself is a capacitance symbol we have taken. So these points are the same potential. When potential is there, capacitance C prime will not be charged. C prime is removed. It is a balanced bridge. C prime, just remove it. This part is removed. When you remove, these two are coming in series. Series means what? C by 2. This is coming in series. C by 2. C series is C by 2. C by 2 parallel to C by 2 is double it. You have to take it up. C by 2 plus C by 2 is C only. So no need to work out the balanced bridge. All are same value given means result is same only. No need to work out that. So result is C. It is a balanced Western bridge. But only thing is you have to be careful with the analysis because circuit diagrams will become balanced circuit. So means just you have to rearrange the diagrams. It is balanced Wheatstone bridge. So all with same values. Bridge, all capacitor equal. That is C. Therefore, CAB is also equal to C only. Whatever the C value given, that same value you have to take. So each value is given CAB. That data is given as C equal to 10. That C prime now given as C1 is 100. This is given as 10. This is also 10. 10. This is also 10. All microfarads. But this one is given as a C1 is equals to 100 microfarad. Whatever it is, it doesn't matter because we are removing it. This is given as a C1. Now we are going to remove that. Whatever value given, don't bother about it. So result is C. What is C equal to is 10 microfarads is the answer for us. Next question 165. 165. Here in the circuit diagram, one capacitor is short circuited, C1, C1, C2. One capacitor, another capacitor, here also another capacitor. This capacitor is short circuited. This is X and right side is Y. C1, C1, C2. So whenever this is short circuited, charges do not store on this. The charges will simply directly pass like this. This C2, whatever short circuit, no, you take it as a wire only. This wire only dominates here. So this is equal to simply the top capacitors C1 and C2. This is X, Y. Here C2 is short circuited. Question is find capacitance CXY between X and Y. In this diagram, C2 is short circuited. Charges are not stored. So what you get here? Only C1 comes in parallel with the C1. Sorry, this is C1. C1, C1. C1 come parallel with C1 means C1 by 2. I think values are given in the problem. Values are given are C1 is 1, C2 is 2. This is 1 microfarad. This is 2 microfarads. This is also 1 microfarad. So result is CXY. C1 comma C1 are parallel. Therefore, CXY equal to C1 plus C1, which is 2C1. C1 is 1 microfarad. 2 into 1 microfarad, which is equals to 2 microfarads is the answer. And next, last question I want to discuss. Remaining problems, please work out. Oh, next, sorry, 2013, two problems I have to discuss, but second problem is very important ones. This case of 2013, first question. A oil drop of mass 10 to the power of minus 6 grams is kg is hanging at rest between the two plates by 1 mm separation, having a potential difference of 500 volts. The charge on the drop, find the charge on the drop. Two plates are taken. Between the two plates, one oil drop of mass m or mg, charge q is suspended. Suspended means weight acting downwards is balanced by upward force. Upward force is nothing but equal to QE. Is supposed to be equal to downward weight equal to mg. So if it is negatively charged particles, the force should be acting downwards. Means if electric field is downwards, the negative charge means it will go upwards. Okay. And you have to find out if they give the direction of electric field, nature also they may ask. Separation of the plate is given as 1 mm, potential difference is 500 volts. So in case if it is a positive charge, electric field force will be upward directions electric field. And you are given separation of the plates is D. First problem, that is case at 2013. 13, no? Mass is 10 to the power of minus 6 grams. Oil drop is at rest in electric field. You have to find Q equal to how much on the charge, on the drop. F equal to QE equal to mg. But you are not given the electric field, you are given the potential difference between these two plates. Potential difference is given as electric field, you can easily find out from that. Okay, Q is equals to mg by E. Okay, and potential difference and electric field relation is E equal to V by D. So this pump becomes equal to mg by E is V by D relationship. You are given the data. What is the data given is mass is 10 to the power of minus 6 kg, G 10, separation of the plates is 1 millimeter, 10 to the power of minus 3 meters. Potential difference is 500 volts. Continue. 10 to the power of minus 6, 10, separation is 10 to the power of minus 3 by potential difference is 500. 0, 5, 1 by 5 is 0.2. This take it to the numerator 9 or 10 or 10 to the power of minus 10 coulombs. Let's check up that step. So we'll get 2 into 10 to the power of minus 11. Answer is given single digit, 10 to the power of minus 11 coulombs is the answer, that is a charge on the drop. Next question, last one I want to discuss now is, in the uniform electric fields in the plane of the paper as shown in figure, at the points circles V1, V2, V3 are the potentials. Those points respectively, compare the potentials here for this. Second question in that same year. Actually it is written KSET including the other JE main, not JE, that time AIEEE questions were there. After this continuation AIEEE questions also included into that of the same year. Other years which are not in the book, no, I will add them later. I will be uploading in the WhatsApp also later. Next, second question. You are given the uniform electric fields and some points in the fields. Electric field is right side, and you are taking some points, imaginary circle you are taking, in that points A, B, C, D. Points are A, B, this is C, this is D. Okay, this is the electric field. You are asked the potentials, compare the potentials. Potentials at A, B, C, D in uniform electric field. Already you know that in the uniform electric fields, in the direction of electric field, potential decrease. If you are taking an equivalent surfaces are perpendicular, always perpendicular to the electric field. You will find the parallel planes of equivalent surfaces, meaning infinite you can take this electric field. These are the potential points. And in the direction of electric field, potential decrease. This is a V1. V2, V3, this is a V4. So here in this direction, in the direction of electric field, potential decrease. So V1 greater than V2 greater than V3 greater than V4. In the direction of electric field, potential decreases. So here if you check up the potentials, same line if you have taken, same line, same potential should be there. So here VA must be equal to VB. But at this point, this is coming little advance. So this is VC. Here VB equal to VA, and this is point is VD. Okay, so potentials decrease in the direction of electric field. So what you get, the relation is VC greater than VB equal to VA greater than VD is the relationship. So VB equal to VA and VC greater than VB equal to VA and greater than VD is the relationship. Okay, that comparisons you just check up in the options. Okay, we'll stop now. Remaining problems are given with the hints, you just go through them, and we have to start the next topic, current electricity.